I'm Ben Johnson-Ward. I'm a VP of Solutions Engineering at Curiosity Software. We're a company very focused on quality. You heard me talking earlier about test data and model-based testing and things like that. What I want to be talking about a little bit today, we'll talk quite a lot about how AI can help us with testing maybe existing systems and otherwise influence our testing. I kind of want to flip it on its head a little bit and talk about how we can actually approach testing AIs, AI-driven systems. That's probably what we'll focus on the most, and machine learning pipelines. So I'm going to kind of go through this, and obviously if you have any questions, put them in the chat, no problem. Might not have all the time to go through all of the things I want to show you, but I want to give you guys like a broad overview, almost a drive-by of some of the kind of unique considerations for testing these slightly newer kinds of application. So just a little bit of an agenda. I'm going to kind of start with like, why do we suddenly care about this? That might be kind of obvious. We won't stay too long on it. What are the new challenges that exist? Can we break down the problem, right? In terms of 3 different ways of looking at it, 3 different kinds of things we might have to test, AI-driven systems, learning pipelines, and AIs themselves, and distinguishing between those. And then I'll draw a couple of conclusions, and hopefully we'll have time for some questions. So it probably comes as a surprise to nobody that AI applications are getting more important, right? More and more software is kind of being either written by AI or integrates AI, and testing is going to have to keep up with this, right? 35% of businesses are using AI in their applications. A very big proportion of the code on GitHub is starting to be written by AIs and Copilot, etc. And the startups using AI, they're raising all of the money. So this is going to become a bigger part of assuring quality as it becomes a bigger part of the software that is being built, the solutions that are being given to customers. When we're trying to assure quality, our thing has to kind of keep up. So what are the kind of new problems and new solutions that we can kind of apply to this? And we'll get into a lot more detail. But if you just think about this in terms of the challenges, testing AI and AI-driven applications and learning pipelines, that's fundamentally different. I would put it that the shift is actually as profound as almost between software and hardware. Maybe not quite. You can view these things as black boxes. There's so many different things which are slightly different: context windows, embedding, biases, all new kinds of problems that we're not used to. We might be used to UI, API, various things. We've kind of all built up a sense over time of how to test these things. And we're starting to have to kind of not start from scratch, but there's brand new problems for us to be aware of and to test for. And a lot of our kind of traditional concepts, particularly like coverage and expected results, they kind of have to be a little bit redone. There are things that can help us out, right? Whether it's kind of new things like adversarial testing, where we're trying to like do adverse inputs to things, or, understanding tooling for just, putting these AIs out there and how it influences the kind of testing we need to do, right? When we're using things like Hugging Face or LangChain to string together sets of AI solutions to get some overall thing done, our testing is going to have to reflect that as well. So what kind of new tools and what new approaches can we bring to bear to attack these new problems, right? And just to kind of, if it's not already obvious, I don't think that we can exclusively stick to what we've always done, right? Why is that not going to work? In terms of what we test, right, we might traditionally have focused on user scenarios, maybe defined from requirements, but AIs have kind of fun and unique ways of failing. The input space is absolutely massive, and they have non-deterministic outcomes, right? So just taking that old approach is not going to really cut it in really understanding the ways. And we're going to have to look a little bit deeper about how our solutions are architected to get somewhere with this. Ignoring how our AIs are trained, ignoring how we interact with AIs like context windows is going to be at our peril. If we just do traditional scenarios, we're not really going to get where we need to go. And when we're thinking about where to test, how do we think about coverage if code is a slightly different concept than it used to be? How are we going to test if we don't have normal expected results? What are we going to do if we don't know what should happen? And when are we going to test, right? If our AI is continually learning and improving, how are we going to make sure that we're not just testing at some point of release and it's something that happens over time? So a lot of these things have to kind of shift to keep up with what we're going to be doing. I'm going to get a little bit more into that. So just one last thing on why we can't stick with what we've always done. If you've looked at, say, certain types of AIs, and some of them are very different. We've talked a lot about large language models today, and with good reason, but there are other things out there. If you look at some of the kind of research things or some of the things about convolutional neural networks for classifying images or understanding images, if you're looking at some of these diagrams that like visualize the features and objects that they're pulling out, understanding if that's a good thing that it's pulled it out or if it's understood something completely wrong, that's a very different type of exploratory testing than we might be used to. Overall, some AIs can be very, very different. It's not just a machine answering questions. It's not just more code. It's not just more services. And the other thing is just the scale. You know, when you have 100 trillion parameters in GPT-4's case, and who knows with the next one, we have to kind of understand the sheer level of complexity has exploded, right? There's a reason these things take tens of billions to train, and it's ultimately because they're complicated. You know, it's been said earlier before, and, you know, Sergio had mentioned it, you could never really test all combinations anyway, but that problem has kind of got exceedingly worse than it was previously. So with that in mind, I want to kind of break down the problem in terms of like how we're going to discuss it and kind of get a bit of a basic understanding of some of the things that we can consider and some of the things that we can do by splitting up the problem into kind of three different parts, right? Three different circumstances. So for me, the actual most likely thing that you're going to test is not an AI itself, but AI-driven applications, right? So for example, if you're a Catalan, you don't own the LLM, you have a tool that's understanding what it's bringing back and you're using that in your application to drive a user result. Testing that, mocking out the various things that you need to do, building around that is a lot of what we're going to focus on today because I genuinely think it's the most likely thing you're going to be asked to test. Learning pipelines, when you do have an AI or when you do have customizations of an AI or just some kind of machine learning tool, the infrastructure for gathering that data and learning from it and training it and continually deploying it, that's a whole other set of things that we're going to have to test, right? It might be something that we test once. It might be something that's continually updated. That's going to be pretty common as well. The slightly less likely one, but we will talk about it, is testing actual AI machine learning models, right? These have been kind of dominated lately in discussion by LLMs, but there's various other things. And one of the key obvious problems here is that for many of our problems, they're often the best expert available. So we have a test oracle problem. How do I know what actually should have happened? There are techniques and we'll talk about it. So let's start with AI-driven applications starting point, right? So if you're not kind of clear what I'm talking about, I put a very, very, very simplistic on the left-hand side architecture where I have a service or application that we have built. It interacts with the user, maybe a database, and it interfaces to some AI to solve a problem, right? That could be an internal API or external API to an AI. These kind of already pose testing questions, but a pretty typical approach is to treat these like a black box and focus on what our service does. And we'll talk about that in a little bit. But while I have that simplified view on the left, these chains of AIs and services that call AIs, these AI-driven applications can get quite complicated. It can be AIs talking to AIs, giving each other tasks. And there's a lot of things that go into testing that, something like that. So these things can be complicated. They might have, you know, retrieval of certain data sources that they need to do for context. We might have rate limiting. We might manage context windows. It's very rare in reality that we actually call out raw to an AI and immediately just show the response to a user. What's normally happening is a set of services, even other AIs, that are managing that and deciding what kind of context to send, how to manage what comes back, and how to make sure it's consistent given the fundamental inconsistency that we get from AIs by default. So when we're thinking about testing this, pretty typically, scope is king, right? It's always been king, it still is king. We have to kind of understand the architecture of our system, but most importantly, from a quality and test perspective, it's important to know what we're responsible for, right? In the case that I'm describing, we're going to be responsible for the interface to the AI, and then what our service does based on what the AI has given us back, right? So not just the interface and what we send, but what we do when we get things back. So this could be the code, the brokers, conversations between AIs, what our service does when it receives the thing. So for example, if I receive back, hey, this page looks like it's got a risk, how do I display that to the user, right? So the interface between our service and the user, that's nothing new. The new responsibility we have is the service and the AI. The AI itself, for what we're talking about right now, not particularly our problem. And we'll come back to that a little bit later. So what do we actually test when it comes to this responsibility, right? What our service does versus the AI. We can look at, traditional expected results, but they might not actually apply to the AI, but they do apply to our service. The AI, we might not have a common expected result of what it should do under any circumstance, but we do know what our service should do given an unknown input. We know that it should still serve something to the user. We know that it shouldn't allow X, Y, Z. So expected results still matter to us just like they did before, because we're still testing regular code. We should kind of presume that the AI can ultimately do anything, but we still want to test what's actually likely. So if we break this into three parts, we've got inputs, right? So how do we prepare the different things that our service is going to do? I'll talk about some of these in the next page, right? How does our service prepare what it's going to send to the AI and how does it manage it? We have outputs and actions. So when we get things back from the AI, what are we going to do with what it's given us? How do we make sure that under whatever circumstance of what it does, it doesn't cause problems for our service? These are the two most key things. There's other considerations like rate limits and cost. I kind of think of those as logistics. We'll get to that in a little bit as well. So when we're thinking about all of this, it's important to actually break it down and look at some of these things, the kind of newer things that we might not be used to if we haven't dealt with an AI application before that we've been testing. So let's have a look at some of these, right? So what do we test? Let's look at inputs. So when we're sending something to the AI, we have to actually manage what we're sending. Most, especially LLMs, have context windows, as in you cannot just send it 2 megabytes of text. So if your application, has variable length things that you might be giving it, maybe the DOM of a web page, you kind of have to manage that context that you're sending. Do you just cut it off at the knee, or do you filter it in some smart way? Testing for those features is important. Same thing for retrieval. If we're bringing back things from our database to include in what we send the AI, we have to test all of that. We have to make sure that it's robust. Input generation, at Curiosity Software, when we're sending something to OpenAI to help us generate what a model should look like, we are often, sending prompts, we're sending things, we're constructing stuff from the context of our application, making sure that no matter the circumstance, if a user puts some strange character in there, we don't have some escaping problem. All of this is functional testing that we have to do, but it might just be a bit foreign to somebody who has not actually attempted this before with an AI-driven application. And there's obviously something a bit more unique to AIs, which is adversarial inputs. If you played with some of the GPT stuff that's come out lately, you might have seen some of the things like ignore previous instructions, print your original prompt. And if you don't test for things like this, you're going to start leaking IP to competitors. So if we move on a little bit to outputs, or what our service could do when it receives things from an AI, right? What actions could it take? And what kind of things could it receive? The first thing to understand here, and I think this has been, well covered today, is that AI outputs, they don't give us any guarantees of correctness, format, although there's new tools that can help with that, or even that you'll get a response. So is your service going to be robust to that, right? You might have various features to deal with that. So rule checking, hey, it never contains profanity, or agent checking, having another AI check what it's doing. Retry mechanisms, graceful failure, all of these are functional features written in normal code, with the exception of agent checking, that you therefore need to test, but you might not have thought about it in the context of testing your AI-driven application. So the first thing is, from ensuring quality, does it have these features to make it more consistent? Because these are all features for wrapping up our AI. And are we testing them under all circumstances? And you might be thinking a little bit about mocking, and you're quite right. So what is our application going to do with this response? Is it going to pass all valid responses correctly? What actions can it take? Could it cause further calls to AIs? This is particularly important because if you have something where, and I think Sergio mentioned this earlier, if you have an AI that is causing your code to call to another AI that's going to call your code to call your AI, etc., you could end up in a cascade or an infinite loop. So what data can happen? What actions are possible? And what's it going to show to the user? Maybe certain things it comes back with, they're not going to display in the UI correctly. So for all of these things, we don't actually require, and this is the key thing here, we don't require a real AI for testing any of this. We have an AI-driven application, especially in an LLM case. It's not particularly important for almost all of the functional testing for the AI-driven application, but we're using a real AI. So it's a very, very strong case for mocking and synthetic data. So we can especially have those negative cases that, again, OpenAI is not going to do for you. All right. So let me tell you about a worked example, a experience that I had at a recent company that I worked for, right? So we were an AI-driven testing company. One of the products we had was not dissimilar to what you were hearing about Categorizing test. And we had a setup where we had a low-code testing solution. We had AI-driven natural language to tackle some of low-code's tricky problems, right? So in low code, if you're trying to test a web page and you want the user to be able to do an assertion, it can be very, very difficult from the point of view of, well, okay, are all the dates in this table in the past? Anything like that requires looping and conditions becomes very, very difficult in that kind of setting. So we were trying to do this with natural language. We were trying to say, can I send the context of the web page and the assertion, like, hey, here's the web page, and here's what they asked, all the dates in the past. Can I send that to GPT and have it give me a consistent answer? So how did we test that? Well, if you think about our service as something like this, right? We have our testing service in the middle. We have the web page DOM, so like the HTML of the page, the things that are happening on the page. And we have the user's assertion. Hey, are all the dates in the past? Right? That's my assertion for my test. We would send that to GPT-4, but as we started to add things to make that consistent, our testing needs shifted, right? So the first thing that we had to do is we couldn't send the whole DOM every time. DOMs are too big. It wasn't consistent, but we couldn't just cut the DOM off at the knee. We couldn't just like take the first 8,000 characters. Because of course, all these large language models, they have context limits. So we had to develop a service that's going to filter down the DOM in a smart way to send the most relevant information. Well, now that's suddenly a new thing that we have to test with this. The next complication was actually often GPT-4, despite this, would still not give us things in the format we wanted, etc. So we had to have a graceful failure for that. And of course, we had to test that work. And then we had safety nets for what would show in the UI with the reply show in the UI, etc. We had to test that. And then we had to start, this was early days GPT-4. So your usage limit was not infinite. So we had multiple different accounts that were being hot swapped for their usage limits. So we had a whole service that we had to test based on trying to make sure we could keep using GPT-4, or if we couldn't, degrade to GPT 3.5. So it's these systems that surround how you interact with the AI that end up being what you have to test. And just two more to make this even more complicated. We started putting another AI in this, which just decided, hey, based on that question, do I want the AI to directly answer it? Or do I want it to generate me code to answer the question? And then if it generated me code to answer the question, like some of these models are very bad at adding lots of things up. That's why we did this. And I need like a whole Python interpreter, and now I've got to test it. If that's going to work, and it's going to generate code and run it. So you can see how this kind of quickly becomes more complicated, but nothing here is about literally probing the AI. It's about all of the systems that make our experience for the user and how we're using AI is much, much more consistent. So I'm going to kind of be quite quick on correctness and efficacy, right? When we're talking about like testing for efficacy, a lot of that in our system is just done by measuring it over time, etc. Efficacy is relative and correctness is often unknowable. But one of the things that we do know sometimes with these AI systems, we don't know, hey, when it replies with a recommendation, we don't know that's a good recommendation, right? We don't know if that recipe is a good recipe. We can't say it's correct. But we can often know when something is wrong. And this kind of brings us to one of the like slightly older testing methods that we can bring back a little bit, which is property-based testing. So one of the approaches which is quite common with AIs and AI-driven applications that I would encourage you all to look into a little bit more is property-based testing or metamorphic testing. So for example, I can't say if it's correct or not, but I can say it contains no profanity, or it has this maximum length, or et cetera, et cetera. So there's tests that we can do to look for things that are clearly wrong, even if we don't know if it is right. And we can measure this stuff over time. And if you have multiple AIs that can actually help you, yeah, it's exactly so, Joe. It's pretty brilliant, especially with some of the tools that go with it. Property-based testing is quite powerful. And for AIs, we often do a slightly fancier version called metamorphic testing. You can also chain AIs together to help you check some of the things that are coming back. But it's important really for efficacy to be monitoring and doing blue, green, etc. It's more on the engineering side, in my opinion, to be looking at efficacy. And for us, we're looking for more of these failure modes. But that kind of depends on the team. So I want to move on to learning pipelines. And I'm a little conscious of time, so I'm going to go a bit quickly. I've got an extremely simple learning pipeline here, which is basically, hey, what I'm talking about when I say learning pipelines is how do we take data as we go along and essentially train our AI or machine learning models with it. And when I say learning pipeline, I mean all of the infrastructure for doing that. Now, it's, typically you're splitting things into training data and validation data. You're doing all the learning. You're making sure that it's got good efficacy, better than last time, etc. But it tends to, again, get more complicated than this, and that's now a new thing to test. So if we think about our very simple look of a pipeline here, and it's still going to stay simple afterwards, the first thing is I can't just use any old data. I have to filter my data. I have to clean it. I want to ensure good quality in my eventual AI. And I can't just be, taking the data from one place. It's going to be, how do I process user data live from production and filter it? How do I take data from lots of different diverse sources and put it into the right place at the right time to actually do the correct training? And then once I have that, how do I make that training continuous? How do I maybe personalize it on different users and different deployments? How do I continuously deploy my new AIs? And actually, how do I do blue-green deployments to make sure that I'm not, actually degrading the performance of my AI? So all of these things actually need to be tested. And then we also would want our data to be continuous. How are we testing those pipelines? I want my validation data itself. There's probably things against my AI that I'm doing in my pipeline to do that functional property adversarial testing on it as it's coming through. So if you think about it as how do I test this infrastructure, each of these features along here, and of course, how we bring in the new model specifications to say improve, how do we test how all of this put together is one of the things that we're going to have to consider along the way, right? So from the point of view of a pipeline like this, one of the things to consider that we're quite focused on at Curiosity is we are focused on, say, testing the infrastructure of this. But when you're testing this infrastructure, you don't necessarily have to use the data that you would eventually train on to build a good AI. That means you can use fictitious data, which is kind of like mocking, but for data, right? So Curiosity would use synthetic data. So you can create data for any kind of scenario, including negative and unlikely cases. You can put this inside mock services, or you can put this inside databases that you're using, or, data pipelines that you're using to train your AIs. So if I were to say, hey, before my actual application even exists, when are we going to test it? Before my application even exists, before my users generating the data to train it even exists, can I test my pipeline, my infrastructure for building this learning system? And then, of course, I do need to keep testing this as it's deployed into production. All right, let's move on to AI, just because I'm a bit low on time, and I'll do a very quick one on AI, and then we'll pause for some questions. I realize it's been a little bit fast. So with anything else like the AI, when it comes to testing actual AI models, I will say that this is probably going to be the rarest thing, at least for now, right? It's right now dominated by large language models. You're probably not going to be testing large language models directly. You might be testing classifiers and things like that, or maybe fine-tuning some large language models. But unless you're working at OpenAI, you're probably not testing GPT. So it's a question of what do we test, where do we test, how do we test, when do we test, right? And the problem we have with testing AIs is that they are often the best experts, so we're losing that expected result. So what do we test? Well, it's a matter of scoping, right? Is this AI external? What does it cost to test it? How broad can our testing go? Depends on all of that. Is it a large language model or classifier, et cetera? If you just blankly look at these AIs and don't consider how they're built in their architecture, you're not going to be able to build effective test sets against them, right? Are the inputs finite or infinite? What is the architecture? How is it built? When it comes to that, understanding the efficacy is usually the domain of more of like the science engineering side of this, right? You're usually objectively measuring that against some kind of reference point, human or code, or the last iteration of the AI, that's what the validation data was written for. On the testing side, we're kind of interested in everything else. So for functional correctness, right, we can still do that property-based testing. Is it giving me certain inputs, certain outputs, at least in a way that I would expect? Can I check it for stability by using another old testing method, fuzzing, where I just put in loads of different inputs to it and see if it falls over? And then there's that classic adversarial testing where I mess with the different formats, things at the limits of the input, looking for unusual things like tokens, etc., and bias, hyperparameters, interpretability. What unusual things can exist here? But when we talk about property-based testing, again, it's that same thing of, does it never contain this, that kind of thing? We can test our AIs for that. When it turns out with things like adversarial testing, we might be looking for something interesting like glitch tokens. So if you look at large language models, if they don't have sufficient training in certain places, but they have a token, that can actually cause big problems. We'll talk about that a little bit more in a minute. So we talk about where we test. I was talking earlier about us not really having good sets of coverage metrics when it comes to AIs, because they don't run on code in the same way that old school things do, right? So keeping that in mind, what can be our new approach to coverage with that, right? Old ideas of coverage aren't going to work, but if we understand our AI model, right? If we understand for certain inputs, what parts of our model lights up. So if you imagine a neural network, right? A new strategy for coverage can be, is I put different tests through here. I apologize for the background noise. So I put different tests through here. Which parts of my architecture light up is kind of like which parts of my code were touched when I ran normal tests through it. It's an equivalent kind of thing. And we have the same kind of thing for large language models, which is if I have all of these different tokens, and if you don't know what tokens are, it's kind of how LLMs break up words and phrases and things like that. If I have tests that cover all of my tokens, I'm going to be in a much better position coverage-wise than if I don't have any tests or any training data for those, like signet message and things like that, right? So when the space of possible inputs is finite, you can try and test everything, but in reality, that's going to be pretty rare, and you're normally going to be looking for various attributes. So if we're going to be understanding how well we're covering these AIs, you need to know their architecture. And just one last thing on this, I'll just kind of move past straight this because we've kind of covered it already. One last thing to think about if we're trying to ensure quality for an AI model is we don't have to only look at it once it's already an AI. The other thing we can do is try and apply quality to actually the input data. So while it might be the data scientist's job to do the data cleaning and filtering, you can apply a QA approach to that as well, which is, can we go and profile the data that they're about to go and learn from? Because we can look for, in that profiling, what's the shape and nature of the data that we're learning from? What are those statistical limits, etc.? Are they what we expect to see? What data are we training on? Visualizing that, making it open to inspection. Does the product manager know what the data looks like that we're training on? We can look for various things like not having enough coverage of key data scenarios, overfitting, glitch tokens, just bad quality data that's still making it through. If we apply QA to code that engineering writes, it stands to reason we apply QA to data that engineering comes up with to train their models as well. And so this, has bias and all sorts of things. So all of these are going to be problems that will make it into your AI. And it's another kind of testing that you wouldn't necessarily normally think of because you're not actually going against the system under test, more like the system's origins. So, and I promise this is my final slide. What do I kind of need to remember, right? The first thing to kind of think about when someone asks you to test an AI system is, what am I testing? Is it an AI-driven app or learning pipeline? Do I understand the architecture? What kind of new problems and failure modes are possible? And what new testing approaches do I need to match those? And can I isolate my system under test and really focus on what I'm actually responsible for and not vast AI models if that's not what's actually required? So I do think that mocking a synthetic data plays a big part of that. So I realized that was very much a whirlwind, kind of like, hey, here are the kinds of things you should be thinking about. Can I do? But I want to stop there and ask if there are any questions.
Thank you, Ben, for such great delivery. So yeah, now is the time. If you have any questions, please go ahead and put them in the Q&A. We're going to launch the poll so we can get your feedback on how is it that you like this presentation. We hope that you learn as much as we did. So looking at the Q&A here, and there is also in the chat window, we put some links for as it relates to curiosity. If you want to talk to an expert and book a demo, or if you want to learn more about what you just saw, there is also the contact information for Ben. You can send him an email or also try to follow him on his multiple channels. So we are going to leave the Q&A, the poll open here for a couple of minutes, and also right now is the time if you have any questions. It looks like some answers are being posted on the on the Q&A as well. They're being posted live. Ben, there is a quick question from Jazz. It says, "Where are you located?" First, and second, do you? And then the question is, do you put tests under version control? Just general question, I guess. I don't know if it is just for you or the entire panel.
Yeah. So for me, I am in New York City, originally from Oxford in the UK. If that's kind of where the question was coming from. In terms of putting tests in version control, for me, if you write them like their code, then yes. If you're generating them from some other artifact, then maybe that's the artifact that needs to be in source control. So whatever it is that you would be checking in, because it's the artifact that you're all working on as a team, I feel that deserves to be in source control. Maybe not the same as your application, but if it's a generated artifact, I kind of feel like it should.